Hello everyone, my name is Siddharth and I'll be introducing a topic for this project which is the multimodal data fusion for early risk detection. In this presentation, we will focus on how combining different types of data can help identify students who may be at a risk earlier. The main idea of that is that instead of looking at one type of data, like grades alone, we combine multiple sources to get a better understanding of the students' performance. For this project, we selected two research papers from top data science conferences. The first is by Lakaralu, who focuses on using machine learning to identify students at a risk of poor academic outcomes. The second paper looks at predicting student risk using data that has been collected over time. We chose these papers because they both focus on early detection of student risk, which directly connects to our project. They also show how combining different types of data can improve predictions, which is the core idea behind the multimodal data fusion. Now we'll talk about the problem and the approach for the project. One major problem that is highlighted in these papers is the is that students are often identified as risk too late, which means that the students are it is too late by the time the students are identified, and by the time the schools intervene, it can already be difficult to improve outcomes or help the students effectively. Another issue is that data is fragmented, meaning it exists in different places and is collected separately. For example, the academic data might be stored separately from the demographic or the socioeconomic data of the students. Because of this, schools are not using all of the available data and information effectively, and most of the time they're looking at each data set separately instead of looking them combined. The approach proposed is to combine all the different data sets, such as the NCES data, which includes school performance, and census data, which includes socioeconomic information. By merging these datasets using tools like Python, we can analyze patterns across multiple factors and get a more complete understanding of the student's risk. For the multimodal data simply means that using multiple types of data in combination together instead of relying on single sources. For example, instead of only looking at grades, we can also include attendance, the family background, and school level information. When we combine these different sources, we get more complete insight and a picture of the student's performance. This helps us uncover patterns that might not be visible when analyzing just one dataset or might not be visible at the surface layer. For example, a student might have average grades in class, but when we combine the the grades of the student, his or her absences, which might be high or low, and also certain socioeconomic factors and background factors, you might discover that that student may actually be at a higher risk. This kind of analysis can support better decision making by helping educators take action earlier and in a more effective way, which will be helpful for the students to grow and improve. Now, I'd like to pass it on to Santiago to help share more information in the topic.
The first paper we selected is by Lacarajo and others, and it was published at the KDD conference, which is one of the top conferences in data science and machine learning. This paper focuses on predicting students who are at risk of not graduating on time. This is an important problem because in the United States, a large number of students do not graduate on time every year. According to the paper, this has long term impacts on students' careers and also affect school resources. Traditionally, schools rely on things like teacher feedback or simple rules, such as low GPA or high absence rate, to identify struggling students. But these approaches are often limited, they are static, not always accurate, and don't generalize well across different schools or student groups. So the main issue is that schools are reacting too late instead of identifying risk early enough to actually prevent problems. The goal of this paper is to move from a reactive approach to a proactive one by using machine learning to predict which students are likely to struggle in the future. Now I will explain how they actually do this. Methods and findings. The author used historical student data collected from two largest schools districts in the United States. This data includes things like GPA, attendance, behavior, demographic information, and other academic indicators. They then frame the problem as a classification task where the model predicts whether a student will graduate on time or no. They test several machine learning models, including logistic regression, decision trees, support vector machines, and random forests. Each model tries to learn patterns from past student data and apply those patterns to predict future outcomes. As shown in this graph from the paper, the performance of different models is compared using something called a ROC curve. On this graph, the goal is to have a curve that is as close to the top left as possible, which indicates better performance. Each line represents a different model, for example, random forest, logistic regression, and decision trees. What we can see here is that random forest model consistently performs the best across both datasets. This means it is better at correctly identifying students who are at risk while minimizing incorrect predictions. In practice, this means schools could use this type of model to more accurately identify which students need help. This second graph shows something. The second graph shows something. Instead of accuracy, it focuses on how well model ranks students by risk. The idea is that schools don't just want to know who is at risk, they want to prioritize students based on how much risk they have. This is important because schools have limited resources and can only support a certain number of students. On the x axis, students are grouped from low risk to high risk. On the y axis, we see the actual percentage of students who are ended up not graduating on time. A good model should produce a smooth upward curve. That means students who are ranked higher are actually more likely to be at risk. If the curve is not smooth or goes up and down, it means the model is ranking the students incorrectly. That could lead to schools helping the wrong students, which is a big issue when resources are limited. So, this graph shows that it's not just about predicting risk, it's also about correctly prioritizing who needs help the most. Overall, the paper that machine shows that machine learning models, especially random forests, can accurately identify at risk students early and rank them eff- effectively. This is directly relevant to our project because we are also trying to identify risk. The difference is that instead of using only student labeled data, we're combining multiple data sets like education and socioeconomic data to gain a broader understanding of risk. Now I will pass it to Jocelyn, who will explain how combining multiple types of data can further improve these predictions.
I am covering our second paper, which is predicting students' risk through longitudinal analysis by Damane and a team from IBM Research. This IBM paper shows how to handle a kind of messy multi-year data we need to actually get predictions right. The big issue the IBM team pointed out is something we see everywhere in education, which is the data is usually fragmented. Schools actually have a lot of information, but it is usually siloed, and which means the data points are in different systems. For example, the test scores might be in one system while things like attendance or discipline records are in a completely different one. Often these systems don't talk to each other, making it impossible for the administrator to see a student's full profile. The author explains that if you only look at a source from one of these systems at a time, you're only getting a piece of the story, which will only provide a limited insight. You might be able to tell the student is struggling academically, but you won't have enough context to see the behavioral or environmental why behind it. Without that why, the intervention from anyone who tries to fix it is basically just a guess. Their solution was to use longitudinal analysis. They looked at a student's whole journey over several years instead of just taking a snapshot of where they are today. This shift is crucial because a student might have one bad semester due to a temporary issue, but the longitudinal view helps distinguish between a one-time dip and a downward trend that's been building for years. Since we can't really get a full story from just one system, they needed a way to link everything together. Now, if you look at the diagram here, you can see how they organized all that data into four main buckets: student tests, test details, school, and teachers. As the paper mentions, they pulled all of this from a central data warehouse. This allowed them to take over 100 different tables and consolidate them into these four broad categories. The teacher bucket specifically allowed them to link students to their specific instructors and course history, while the student bucket tracked things like enrollment, demographics, and test performance. In addition, instead of just looking at one year, they used data for students over the years. This means they weren't just looking at a student's current scores, as I previously mentioned. They were looking at their course history and their performance in various tests they had taken so far over the years. By looking at this history, they were able to see a student's full academic path rather than just a single moment in time. Through this process, they were able to find that they could predict an eighth grader's success or failure by looking at data from as early as fourth or fifth grade. This is a significant finding because it shows a 3 to 4 year lead time. It suggests that the path to a student's success or failure isn't decided at the last minute. The paths are actually visible earlier if the data is linked correctly. This allows for fairly accurate predictions long before a student actually reaches a crisis point. With that, I will pass it over to Varshini.
Here we come to the strengths and limitations. So these papers show strong real-world applications and highlight how data can improve decision making in education. So, however, there are also limitations such as dependence on data quality, potential bias in models, and concerns around privacy. And so, how it connects to our project? Our project builds on these ideas as shown by combining datasets like NCS and census data. Instead of focusing on individual students, we analyze patterns at a district level. This makes our approach simpler but still scalable and meaningful. So, here in conclusion, combine multiple datasets allows to uncover patterns that would otherwise be missed. So, when combined with AI, this approach can help identify this earlier and support better decisions in education. Thank you.